16. So the circle is usually defined by a locus of points at a given distance from a given point, the center. There is another, also less known definition of a circle using two fixed points, that a circle is a locus of points such that the sum of squares of the distances to two distinct fixed points is a constant. In the article of Missouri Journal of Mathematical Science, author John Stetson, by using dynametric geometric software in constructing loci with various conditions placed on distances from two fixed points. The center of circle is at the midpoint of line segment CD. It also must be mentioned amazing results given in American Mathematical Monthly and Math Horizons, in which authors Tom Apostol and Mamikon Matsikanian wrote that given a finite set of fixed points in 3 space, what is the locus of a point moving in such way that the sum of squares of its distances from the fixed point is constant? The answer is both elegant and surprising. The locus is a sphere whose center is at the centroid of fixed points. In case of plane, this locus is a circle. In our article, we consider 3 points. We will give an answer to the following problem. Is it possible to define circle using 3 points, and what conditions should these points satisfy? In our project, we define a circle by using 3 vertices of equilateral triangle. We consider distances not only in the second power, but also in fourth and sixth powers. Let R be the distances from center of fixed regular triangle to its vertices, L the distances from an arbitrary point M to the center of triangle, and X the distances from point M to the vertices of the triangle. So as we said, the theorem of sum of second powers is already proved. We checked it and got that S2 equals to 3 times R squared plus 3 times L squared. That means R is constant, L is constant, and S2 is constant as well. The locus of points such that the sum of second powers of distances to the vertices of fixed regular triangle is constant is a circle. The center of a circle is at the center of regular triangle radius L satisfies following condition. S2 equals to 3 times R squared plus L squared, where L is distances from an arbitrary point M to the center of the triangle, and R is distance from the center of triangle to the vertex. After that, we tried to find theorem about sum of fourth powers as well, but we couldn't find it anywhere, so we tried to do it ourselves and got that S4 equals to x1 to the power 4 plus x2 to the power 4 plus x3 to the power 4, introduced new notations that A is R squared plus L squared and B is 2RL. After simplifying all these equations and using trigonometric identities, we got that sum of cosine squares is 3 over 2. And S4 equals to 3 times R to the power 4 plus L to the power 4 plus 4 R squared L squared. The obtained expression only depends on X, R, and L. R is constant, so S4 is a constant, then L is also constant. The locus of points such that the sum of fourth powers of the distances to the vertices of fixed regular triangle is constant is a circle. The center of the circle is at the center of regular triangle, the radius L satisfies following condition. S4 equals to 3 times R to the power 4 plus L to the power 4 plus 4 R squared L squared, where L is distance from an arbitrary point M to the center of the triangle, and R is distance from the center of regular triangle to the vertex. After that, we tried to do the sum of 6 powers as well, but unfortunately, after trying and introducing all the notations using trigonometric identities, we got that S6 has cosine alpha angle, that the sum of 6 powers contains alpha angle and alpha space, so in this case the locus would not be a circle. But there are certain points that, these red points, when even the 6 powers could be constant, but in general it's not constant, but sum of second and fourth powers are always constant.